Hi folks, today we're going to be going over the 15s. I always encourage you to try the problem before you watch me do it. So these first four problems, give them a look, see if you can figure them out. Then I will definitely go over it. So pause it, give it a try, and then I will go over it. You'll always learn better if you try it yourself first. So question number one was, which has the most hydroxide ion? So I'll be looking at A and B because those are the only ones that have hydroxide ion. I have one drop of a 0.1 molar. I have two drops of a 0.2 molar. So in this instance, I would definitely have to go with B. I have more drops of the more concentrated hydroxide ion, and therefore I should have the most hydroxide ion. For number two, blank is the most concentrated acid. Well, here we're not looking at drops at all. We are simply looking at molarities, and 0.8 is definitely a higher concentration. So the answer in this one would be D. For number three, blank has the most hydrogen ion. All right, so we have 3 drops of 0.4 molar. But here we have 4 drops of 0.8. So we have more drops of the more concentrated acid. So my answer would have to be D here. In a little bit, I'll show you how to do some math that'll back that up. And number 4, which has the most moles of base? So in this one, I have 1 drop of 0.1 molar, but here I have 2 drops of the more concentrated base, which is 0.2 molar. So I have more of the more concentrated base, so my answer would have to be B for this one. All right, number 5. Will mixing A and D be pink or colorless if a drop of phenolphthalein is added to it? So in this problem, we're doing A and D, and will it be pink if a drop of phenolphthalein is added to that combination? Well, if I look at this combination, I can see that D has more drops of a higher concentration acid. So I have 0.8 molar HCl, which is hydrogen ions. And in A, I have 0.1 molar hydroxide. Sodium hydroxide has hydroxide ions in it. So just looking at that alone, I would say this is going to have more hydrogen ions in it. Plus, they tell us we have more drops of this 0.8 than we do of the sodium hydroxide, only 1 drop of the sodium hydroxide. So in this case, I'm going to end up having more hydrogen ions in my container. And remember, to turn pink, you need hydroxide ions and you need phenolphthalein. If you don't have those two things, it's not going to be pink. So in this problem, I'm going to have a lot more hydrogen ions. All the hydroxide ions would have been consumed up with the hydrogen ions, making water. So there'd be no leftover hydroxide ions really in the container. So if there's no hydroxide ions, it's going to be colorless. This is another way of putting it. So right here is what I just went over with you. But now we could talk about the mathematics of this problem. So since we're talking about drops of each of those solutions, we could say a drop is a liter. Okay, and then we could do some mathematics with it. So in A, we started with 1 liter of sodium hydroxide. The molarity is 0.1 molar. We use that as a conversion factor. In 1 mole of sodium hydroxide, there is 1 mole of hydroxide ions. And at the end, we end up getting 0.1 moles of hydroxide. You might need to pause it, take a look at that, and make sure you understand the mathematics of it. Now I can do the exact same thing with D. Here I have 4 drops or 4 liters of hydrochloric acid. I use the molarity of that hydrochloric acid. In 1 mole of hydrochloric acid, I have 1 mole of hydrogen ions. And I end up getting an answer of 3 moles of hydrogen ions in the end. So if I compare these two numbers, I have 3 moles of hydrogen ion to 0.1 moles of hydroxide ion, well, I got a lot more hydrogen ion, and therefore this solution will remain colorless. So please do pause the video, take a look at that math, make sure you understand it. It's kind of key to what we'll be doing in this unit. All right, now we're going to be doing problem number 6. So we're going to be comparing B and C. So in this problem, I have 0.4 molar hydrochloric acid. I got 0.2 molar sodium hydroxide. And I have 3 drops of the 0.4 molar, only the 2 drops of the lower concentration base. So right away, I can tell you I'm going to have more hydrogen ion when I put these two together. So if I have more hydrogen ion than I have hydroxide ion, all of the OHs will get consumed with the excess hydrogen ion and turn to water. And in the end, I will still have more hydrogen ion left over, meaning that this solution would be colorless, even if phenolphthalein was added. So here's what I just said. And here's some mathematics to back it up. So again, take a look at the mathematics, make sure you understand it, maybe pause it, take a look at it, see if you understand it before I go over it. So in solution B, I had 2 drops of the sodium hydroxide, so I can say I have 2 liters of it. I use the molarity in the problem as a conversion factor. And in 1 mole of sodium hydroxide, I have 1 mole of hydroxide ions, and I end up getting 0.4 moles of hydroxide. I had 3 drops of my hydrochloric acid. I use that molarity as a conversion factor. In 1 mole of hydrochloric acid, there's 1 mole of hydrogen ions, and that gives me 1.2 moles of hydrogen ions. So when I compare these two numbers, I have more hydrogen ion, meaning when I mix the two together, all of these hydroxides will combine with the hydrogen ions to make water, leaving us with extra hydrogen ion at the end. And remember, you always need hydroxide ions and a base, which is a base, and phenolphthalein to turn pink. And in this case, there's no hydroxide ions, so it will not turn pink. All right, so please read this over to yourself and then press play after that. So here we go. We have 4 bottles, and they have different concentrations of lithium hydroxide, which is a base, and 4 bottles of an acid, hydrogen iodide. They have the same concentration, so 4 bottles of base and 4 bottles of acid. The 4 bottles of acid also contain the indicator phenolphthalein, which turns pink in the presence of hydroxide ion. Phenolphthalein is colorless in acidic solutions and is colorless in neutral solutions and is pink in basic solutions. So we have to go through all this data and determine if each one's an acid or base of these 8 bottles. So I ask you to pause your screen and see if you can figure this out, and then play it again and see if your methodology follows mine. So in number 1, it says 3 drops of T1 and 5 drops of T5 produce a pink color. So it means I have an acid and a base put together. 2, when 2 more drops of T5 were added to the pink solution, the solution turned colorless. That means T5 must be an acid, and T1 is a base. Again, this one is the base, and this one is the acid, and that's why it turned pink, because we put the phenolphthalein in the acidic solutions. Number 3, when 5 drops of T4 were added to a pink solution, the solution turned colorless. So in this problem, in 3 here, they started with a pink solution, they added some T4 to it, and the pink went away, it turned colorless. So that must mean that T4 is an acid. All of those hydrogen ions are consuming the hydroxide ions, taking them out of the solution, and therefore making it an acidic solution, and phenolphthalein is not pink in an acidic solution. Number 4, when 2 drops of T8 were added to 2 drops of T1, the solution was colorless. But when a 3rd drop of T1 caused the solution to turn pink. So that means T1 is a base, and T8, therefore, must be an acid. Again, you need the acid and the base together to get the pink because the phenolphthalein is in the acids. Number 5, a pink solution stayed pink when 15 drops were added to the pink solution. 19 drops is the most you will ever need to add. So we had a pink solution, we had 15 drops of T3 to it, it stayed pink. Well, it must mean that T3 is a base. Number 6, a pink solution stayed pink when 15 drops of T6 were added to it. So again, T6 is a base because we added a whole bunch of base and the pink solution stayed pink. So that must mean you're adding a base. And 7, added 4 drops of T2 to 2 drops of T7, it was colorless. But adding a 3rd drop of T7 turned it pink. So this must be a base. And by process of elimination, this one would have to be an acid. You're going to be doing labs like this, so it's very important that you try the problem yourself before you look at the answer. So now we've got to figure out what each of these bottles are. So T2, T4, T5, and T8, if we look up at our data, all of those are acids. So all of these are hydrogen iodide all the way through. These are all acids. It says right here in A, it says starting with the same pink mixture in 4 different wells, the following numbers of T2 through T8 were added to turn the solutions colorless. So we started with a pink solution, and this is the number of drops it took to turn it colorless. And then this is the number of drops it took to turn it colorless. This is the drops it took to turn colorless. And then this is the drops it took to turn colorless. So pause the video and see if you can figure out the concentrations of all these hydrogen iodides. So hopefully you paused it and tried to figure it out on your own. This took a lot of drops of a hydrogen iodide solution to turn it colorless. That means this hydrogen iodide must have a very low concentration. So this is the most drops, so this is the least concentrated hydrogen iodide. If we go down to the bottom here, it didn't take very many drops of this hydrogen iodide to turn it colorless. That means that this one must be very concentrated. So this is the 0.8, this is the 0.4, and this is the 0.4, and this is the 0.2. So in this part, it's saying that 3 drops of each of these bases were added to a well, and then 1 drop of T2 was added to all of them to turn them pink, and then it took 24 drops of acid to turn it colorless, and then this one took 12 drops of the same acid to turn it colorless. This one took 3 drops of the same acid to turn it colorless, and this one took 6 drops of that same acid to turn it colorless. See if you can figure out the concentrations of the lithium hydroxide before I go over it. So again, we are trying to figure out these. This T1 took a lot of drops of acid, so this T1 must be very concentrated. If I go to the second one, it took the second most drops of acid, so that must be the next one in concentration. The very bottom one took the 3rd most amount of drops, so that must be the next one in concentration. And the T6 took the fewest drops, so that must mean that is the most dilute. All right, take a look at that, folks, and hopefully you understand what's going on. Your homework is the next page in your unit pack, which is your 20s.